Hello everyone. Today we will cover the Snowflake warehousing. Okay, that how warehouse is very important part of the Snowflake cloud. As you know that there are three layers into the Snowflake architecture: storage layer, computing layer, and metadata layer. Storage layer is basically storing the data into the disk, so it's primarily responsible for that, and services is the brain of the system. Means you can see that metadata of the data, but where the data is actually processing, whenever you are hitting the query, where the data will be pulled and query is processed. So that is your compute layer. That is most important part of Snowflake cloud warehouse. Means either we can say the elastic warehouse, okay, where you can change based on your requirement. So we'll see that how the warehouse we can create and what are the different factors for that, how it's running, when we are changing the size, how it's behaving. Okay. So first we will create one warehouse, okay, with the access small size. Okay. So I will explain that what's the meaning of the size. So Snowflake is billing based on the region or your servers, means cloud servers which you are using, either AWS or Azure or Google Cloud, okay, and which region you are choosing. So it's billing based on that. So what Snowflake is considering that, okay, one credit price in each region, and then in the Snowflake the billing is based on the credit for warehouse. So smallest thing is the access small, that is using the one credit, and after that based on the t-shirt size it's getting doubled. Access small is small, medium, large, x large, 2x large, and 6x large. It's wide. Okay, so all the sizes are available. So maximum 6 is large. Access small size is 1 credit per hour. Okay, so that is there. Okay, but it's not that minimum billing time. Minimum billing is 1 credit. It's no. So house billing, it's minimum billing for the 1 minute, and after that it's billing for 1 second each. So suppose your warehouse is for the 2 minutes 30 seconds, so you will be billed for the 1 minute, and then after that for 1 minute 30 seconds. So total 2 minutes 30 seconds you will be billed. Okay, but if your query is running for the your warehouse is up for the 30 seconds, okay, in that case you will be billed for the 1 minute. So minimum 1 minute time is there for the billing. Okay, now thing is that if your warehouse is up, okay, and you are not running any query, in that case also you will be billed. It's not compulsory that you are running the query, only then you will be billed. If your warehouse is up, it's used or not used, not matter. Okay, if it is there, okay, if you have created the warehouse and it's up, it's not in the suspended conditions, you will be billed for that. Okay, then we are choosing also then cluster size. So this is the vertical scaling. Okay, we can say that how scale up. Okay, so you can say that when you have the your heavy queries, okay, if I'm giving you the example of your system, okay, when you want to run the heavy games, what you are doing that you are increasing your RAM, okay, your processor, means you are increasing the computation capacity of your system, existing one system only. So in that case, okay, x is small, or means we need to increase the size. But if we have the multiple users, means queries is small, okay, it's running for 1 or 2 minutes, but multiple users are hitting your warehouse. Okay, for example, you have the item reporting through the OBI. So in that case, multiple users are creating the reports and hitting your warehouse. Okay, if the same warehouse is considered. Okay, in that case, okay, clustering is most important. That if multiple queries are into the parallel, it can be executed. Okay, So for now I'm considering the one. You will see the example, then you have the multiple clusters and how you do that. Then next is your scaling policy. So two type of scaling policies there. One is standard, okay, means if you have the multi-cluster, then it's applicable. Okay, so if your query is waited more than 20 seconds, okay, automatically new cluster will be added. Okay, so if your query is going into the waiting and clusters are multiple, okay, it will up. But if it is economy, then it will wait for 6 minutes before starting the new warehouse. Then your auto suspend, okay, in the GUI the minimum time is 5 minutes, okay, but we can alter it to the minimum 1 minute, okay, that we can use. Okay, I will show you that how we can alter. Okay, so here I am creating this one. Okay, the warehouse is created, it started. Okay, let me alter this. Okay, alter warehouse, auto suspend. Okay, it should be into the seconds. Okay, so like now we'll see that what is the suspension time. See this one, 1 minute. Okay, now we will wait for 1 minute and see. Okay, it's on the 20 seconds. This is that will it suspend automatically or not after 1 minute. 10 seconds are remaining. Okay, oh, it's suspended now. We are not an any query, so it's suspended. Okay, so 1 minute. Okay, now we'll see that how the queries are running on this. Okay, then we'll compare that when we are changing the size, how it's behaving since we are running on the higher warehouse. Okay, before that, okay, I will show you one concept of caching into Snowflake. Then we will discuss and test that. Okay, I'm running the customer table. Okay, this one using the cache result. Okay, I executed this query earlier. Okay, so I am getting this result from the cache. Okay, I will show you that how it's because I have executed earlier this. Okay, you can see into the query profile. Okay, that from the results. Okay, result cache is reusing the previous result. If your query is same, exactly same, it should be with the same column. Whatever, if I'm running the select star and then I'm using all the column name, it will consider two different queries. Okay, but if your query is exactly same, it will use the cache. Okay, so for testing purpose, okay, I am disabling the cache into my session. Let's use cache result. Okay, right, check that. What is the variable for this? So it's use cached, not cached. So it's there. So use cache result if you are making false. Okay, now if I'm to run the query, okay, we run. Okay, I have to use the warehouse. Okay, I started the queries. Okay, now now if you see that query have started running, so it's using the warehouse, it's not using the access one, it is started. Okay. So whenever it's running from the cache, no billing, okay, nothing is there, but when it's hitting the warehouse, okay, the billing will be there. Okay, it's starting. Okay, suppose in between I am changing the warehouse size. Okay, then okay, suppose I'm changing from small to small. Okay, it will not applicable for current query. On the access small only it's executing. Okay, if I'm starting, suppose in the other tabs I'm starting the another query. Okay, on the different areas. Okay, let me start that. And I'm using the same warehouse. Okay, in this case we will see. Okay, let's start this. It will start on that new warehouse, but whatever the old query which is already executing on the same warehouse, it will be there with the same warehouse size. Okay, there will be no change to this. So this query is running. Okay, and now it's completed. Okay, in a two not this one, this is for the small one. So this is the access one. When we have executed, it took the 1 minute 11 seconds, and complete query is executed on the access one. Okay, now we will execute it again. Okay, we'll see that on which it's getting executed. See, now it's executing on the small size. Okay, I will show that if I am suspending forcefully, okay, how it's behave. Okay, so see, suspend, and if I am using, okay, it's terminated. Okay, I'm terminating this one. Okay, that's it, suspended. Okay, but before that our query was completed. Okay, so let me change the size to access small so we can see that how it's behave when we are suspending in between. Okay, so this is started. We can see this one. Okay, I am suspending it immediately. That's for suspension. Okay, it will not suspend. Okay, it will wait until the query will not complete. Okay, because we have choose that suspend. Okay, we'll see another way also that how it will behave for that, but let's this get completed, and after that we'll see that how it will behave when we want to suspend immediately and upload all the queries. Okay, let this to be completed. 58% is completed. It will take 1 minute and 50-second time. Okay. 73% is completed. This is completed, and now we see the warehouse. Okay, it's also suspended immediately when the query is there. Okay, now I'm running it again. Okay, that's it started. If I want this, it will not suspend. Okay, so what we'll do, that query is running, as we saw earlier that it will wait for the queries to complete. Okay, okay, now I will expect to suspend it forcefully. completed. Okay, see 109 seconds. Okay, now we will increase the size of the warehouse. Okay, okay. Access only EFC. Now I will activate with the small. Okay, you will able to see that what is the difference when we are using the headers, means we have disabled the cache, so it will not use that. Okay, even that we are changing the size, it's not depend on the warehouse which we are using, it's stored into metadata layer. Okay, whatever the result is there, not sorry, in the metadata in the database layer. Okay, it's stored in that, so it will get the immediate result. Okay, and use that, but it's not depend on the warehouse. Okay, any warehouse we are using, it will be use the cache. Here it took the 1 minute 9 seconds. Let's see that on the small how much time it will take. Then we'll see for the head side also that how much time it's taking on those. It's processing. See that reading from the database because we have disabled the cache. Okay, it's running on the access small only. I think that our changes was not applicable. Okay, okay. We have activated before it's restarted. Okay, on the access one only it's activated with a 50% capacity. Okay, let me expand this and restart. Let me change this again. See, now it's running on the small. I will return this screen intermediately, so it's used up with the 50% capacity. It's executed with the similar time. Okay, see, this completed into 35 seconds only. Okay, 1 minute 8 seconds, 35 seconds, almost up. Now let me change the 4 times. Okay, too large. Okay, it's changing. I have to wait to complete. Okay, it's restarted with the last side. Okay, now I will exit this. Now see, execution is started. See, 14 seconds. So whenever we have the large size data set, okay, like here 3 GB data set, so whenever we will increase the size, it will be good that we will be able to get the result. Okay. Now we will see that how Snowflake clustering is working. Okay. So this is the parameters. Right. So parameters we have to use. Okay. So here the concurrency level is 8. Okay. What is the meaning of that? Snowflake on each cluster, means when we are using multi-cluster, each cluster it's supporting the 8 parallel queries. Means if you have 10 clusters, okay, you can use run the 80 queries into parallel. Okay, for testing purpose I am reducing it to the 1. checking the parameters. Okay, it's now 1. Okay, now we see that how the parallel is working. So I will open the 3 sessions. Okay, so what I will do that, okay, I will use one more level of same data set, but I will run with the access small. Okay, but before that I have to disable the cache. In all the sessions. So that it will not able to use the cache result. Okay. And I am using the customer table. In changing the size, I have to change the size first to access small. Okay. Now I will choose a little bit bigger table. Okay, from here 5.2 GB because that is completely into 1 minute. What I want that I can show you that how it's running. Okay. For this one it's fine that we can use for the clustering. We need to use the heavy tables. So for now we can use the small one. Okay. See, this one first query I am studying the executions. Okay. Second also I have started. Third also is started. Okay. All 3 are queries and the execution. Now if I will see the history. See these 2 queries and the queue. Okay, and it's started, so we'll see that how it will go into the running stage. Let's refresh. 6 seconds. Okay, queue time will be there. So it will show that currently it's going into the queue. Then we'll use the clustering and we'll see that how it's starting. Okay, so let's wait for a little more time because it's access small. It will take this time. Okay, see this one is completed. Okay, now next query I think that will start soon. Okay. See this, the next query is started. Okay, so this was the purpose to show you that queries in time. Okay, here if you see, okay, queue time is 1.8 seconds, and now we'll see that when it's executed this query is completed. Okay, we'll see that what is the waiting time, okay, due to parallel queries. Okay, let's see that. Okay, I can show you that both difference. Okay, queue time and execution time. So queue time is 1.8 seconds, or your execution time is 30 seconds for now. Okay, means time is waiting. Okay, let's wait for completion of this. We'll see it's completed. Okay, but see execution time is 1 minute, but your queue time is 1 minute 8 seconds. Okay, means we have to wait. Here it will be more because it have to wait for both the queries. Okay, so this was also completed, and then we'll see that here we have reduced the concurrency level of each cluster to 1 instead of 8. So these queries are not parallelly on one cluster. If that is concurrency level is 8, all 3 will execute parallelly. So it's a different thing. Okay, each cluster also there's a concurrency, but if we have more user, more clusters will be enabled, because even on one cluster we are running all the resources which we have, that will be spread into all three queries. Let's wait for it to complete, then we'll see the queue time and execution time for this. Okay, see this one, queue time is 2 minutes 15 seconds and 1 minute 9 seconds actual runtime, but generally users have to wait the 3 minute 24 second, but actual problem is that runtime is only 1 minute 9 seconds, other time is waiting time for 2 minutes 15 seconds. So that is the bigger issue. So in that case our clustering will be more important for us. Okay, let me configure that. Okay, I'm using the maximum cluster 5. Okay, and in cluster 1 I'm first will convert the standard policies. Okay, then we'll see that how the economy policy will behave. Okay, so okay, I'm starting this one first. Okay, this one second, and this one third. Okay, now we will see that how it's behaving. See, all three are running parallel. Okay, now okay, it's queued because it's not started yet, the cluster. Okay, now it's also started. Okay, now it's in the warehouse. Okay, how many clusters active? Three clusters are active. Waited for the 20 seconds. Okay, how many queries are running? 3. So all the 3 clusters are enabled. Okay, so the cluster, how it will happen whenever requirement, it's not compulsory that all the 5 clusters will run. Okay, so minimum cluster I gave 1, so at a time 1 cluster will start. Okay, and assigning the queries. So it waited for the 20 seconds for each queries. Okay, then it started the cluster. Okay, after completion I will show you that 20 millisecond time is always there. Okay, so first one is completed, we have executed, so this is only execution time is there. Okay, see this one, execution time is there, but there's also initially waiting time was there when the cluster was up. It's 1 minute 9 seconds, 11 seconds and 14 seconds. So it took some time for starting the cluster. 20 seconds is given, but here you can see that it's to wait for the 2 to 3 second times only to start that. Okay, but yes, see, but here if you see that it's longer time, let's take 20 seconds around to start a new cluster. Okay, so now we will see that what is the maximized cluster. Okay, so if I'm using the minimum maximum cluster 5. Okay, minimum cluster I'm changing to the 5 maximized, so this is called the maximized warehousing. Okay, so see, 5 active. Okay, at a time. Okay, I'm starting this. Okay, same again, this one also. Okay, and I'm starting the 2 more. Okay, but it's from cache. Okay, let me run into this. Okay, let me make it false and start this one also. Okay, like that. And here also I now see the queries. See, immediately all the 4 queries whenever I execute it started. Okay, but I have used the maximized cluster, so it will not shut down the other cluster. Okay, until the 1 minute is there. Okay, it will not suspend, so it will wait for that. Okay, now one is completed, we are there. Okay, but even that 5 clusters are here. Okay, so it will not be suspended, means initially itself it's standing with the minimum cluster of 5. All the clusters are running. there's no minimum cluster that it's running 1 or 2. Okay, all the 5 clusters are up. Okay, so these are running. So both the scenarios will cover that how it's running. Okay, and one query is there. Okay, and then we will use the clustering that we enable the clusters, and after that we'll see that how it is running economy policy, so that it's complete. It's completed. Okay, now we'll see that how it will behave. We'll use the economy policy. The same. We will consider the 1 million cluster. The condition is stated off. Step 2 will consider economy. Now for this one we will use the heavy tables, okay, which will run longer because we have to show the 6-minute waiting time. Okay, so we will use the little largest tables which is and bigger size. Okay, I'm starting this. Okay, this is another session that I'm starting. Another one I'm starting. Okay, these 4 queries I have started. Okay, let's see. The warehouse. Okay, economic policies there. Our active currently means is not suspended. Okay, so let's see. Okay, for now I'm uploading all the queries. Okay, let's complete because these are the small queries. Okay, so problem was that that we have used the maximum cluster and it's not suspended yet, so all 5 was active, so I will suspend it. Okay, and we'll start again. You will see that because I have changed to maximize clusters. Okay, so I will not do it manually. When I will execute the query, it will automatically and it is where I am starting this query. Okay, and I am starting the second one, third one. Okay, and fourth query I have started the parallel. Now it's economy. Okay, so we will see that how it's not starting the cluster. Okay, here also. Okay, it will not start until the time is there. Okay, it will wait for that. Okay, for the economy policy timing. And then only it will start the cluster. Until that, all the queries will be in the queue. Okay, I will show you that when the concurrency level is 8, how it will work. Okay, that I will show you. Like this query should get complete, and we'll see that how it will behave. it will wait for the 6 minutes. Our query is running for less, so it will not start the cluster for first one. Okay, like start the 2 sessions more. Okay, so if it is more than 6 minutes only, then it will start the query. Okay, so let me enter the sessions. Pause 2 sessions. Starting. Okay. Let me start these also, so I can show you that after 6 minutes it is starting the cluster. We'll wait for the 6 minutes. Okay. It will be fast forward to you, but you're able to see that it will wait for 6 minutes, then it will start that. All horizontal queues, okay, one is running, okay, all of the 5 queries are into queue. Okay, so time between the queries are there. Okay, based on the status I have to sort. Okay, status. Okay, data filters. Good. Multiple stages. Okay. This is first is running and others are there. So we have to wait, okay, until these are running. Okay, let's see. It's completed just now in 3 minutes, and this waiting time is this. Okay, so you can see that cluster is still at one only. It's 4 minute waiting time for this. It's running, but issues might be this or this warehouse and this query when the now new cluster will start into the warehouse. Let's wait for that. 4 minutes, and see that warehouse this is still one. We have to wait. query started, 5 minute waiting is there, but still for these three, the waiting time is 3 minutes. So hopefully it's running in 1 minute 48 seconds. Waiting time was of 5 minutes 18 seconds. In this case, the warehouse is not started because it's still not exceeded for any query. The queue time is more than 6 minutes. So until that is not there, the query will not start. For these, it's near to the 5 minutes, so hopefully these will be there for 6 minutes, and then we'll be able to see that. Okay, so this one is complete and next one is about to start. Okay, no warehouses, no cluster is also started yet because no query waiting time is exceeded more than 6 minutes. Okay, hopefully in any form the time will exceed for more than 6 minutes, and then we'll be able to see that how the cluster is working in the economic policy. Execution time is only that limited times which we are using. The queue time is long for these two for network discipline, but no warehouses added up here. Let's assume that should increase now. 6.53 seconds is there. Hopefully warehouse should be up now. So this started with another queries into the queue, and that is not started. Okay, that is strange. But this is query. Queue time is 6.39 seconds, and even that plus this started here. Problem is there that it will check for the 1 minute after 6 minutes also that if the cluster will face estimated time, then only it will start the cluster. So here you see that warehouse will be free into 1 or 2 minutes, so it's not starting the cluster. So always it's not used good to use the economy game until it's that user can wait, otherwise see this queue time. Okay, now it's started because it's identified that it's starting soon, so no cluster is up for us. Okay, even that it's running with the minimum one cluster. Okay, and see that runtime, actual runtime is 9 minutes with a waiting of 8 minutes 54 seconds, and even the access is not started. So that's to use by a standard clustering only economy when you have the waiting time and with that it's good. Okay, otherwise just avoid that. Okay, now parallelly we will change the eight. Okay, maximum concurrency level we are changing. Okay, compute, sorry, compute. Okay, we have changed this, so we'll see that when we are changing this how it's behave. Okay, let's complete it, and after that we'll see that how it will behave. I will run 3 parallel queries. This time it's completed on 39 seconds, almost it's about to complete, but even that is not started. Okay, so I'm changing the warehouse clustering to 1. Okay, again I'll see that how concurrency will work. Okay, so I will run the 3 queries. Okay, 3 to 4 queries parallelly. It means on the same cluster it's running. Okay, so I've set the concurrency level to 8 on the single cluster. See, all the 4 queries is started. Okay, but what is the impact that we'll see. Okay, here see that by default it's running, first query is running into 1 minute 51 seconds. Okay, when we are running with the multi clusters, almost it's around 1 minute 50 seconds for the 4 queries, but when we are running on the same cluster 4 parallel queries, that will impact the runtime. We'll see this. 30 seconds are completed. Almost 1 which is complete, and which is 11%, 18% is are completed. The first one we have started these, so these are using the resource of same cluster. Okay, so after completion of this, okay, we'll see that how it's impacting when we are on the current queries on the same cluster. Okay, even that no queue time is there. Okay, it shows that how can impact the runtime. Wait for the few more seconds. Okay, that will exceed the 152 seconds where we have the actual runtime of the previous queries. Okay. 28 million is completed. We have around 67 million for each. Okay. 8%. Count earlier when we have this. Okay, it's 100 million. So we have used the heritage, not the small one. The 65 million we have used 100 million. Parallel queries also we have used 100 million. But it's took the 1 minute 50 seconds for 65 million. It's only took the 1 minute 9 seconds. So that we see that what is the impact. See, this is the impact when we are running the queries in the 2 minutes, only 33% queries are completed. Take a little longer. Let's wait that by when it will complete. So running the queries, 30%, it's coming from the cache. 446 are scanned, 1024 are remaining, country size is 2449 GB, and still the share is progress. Need to wait until the activities will not complete. Around 45% is completed. Most time is almost 1.5 times, so previous query is completed by at 1 minute 50 seconds. Now it's more than 0.5, around 3.5 minutes. Wait, move. It's almost completing to the 5 minutes 50 seconds. 60% almost. Wait. 71% on the 5 minutes 3 seconds, almost 3 times of the previous time. About to complete, 81% is completed, almost 1 minute. It will not take more, and then you'll be able to see that one cluster, if you are running concurrent queries, it can impact our performance. So always you want the best performance. Okay, like you can be there, okay, but keep up one concurrent level, one or two or three maximum, one or two. Okay, and then use the multi-cluster. If you're using the directly multi-cluster, it will not be helpful. Okay, it will be better that you use the this one local and remote. So this is in fact okay. See here it's using the remote. Here local means it's using the disk. Remote means it's using the cloud. Means warehouse, RAM. This is your hard disk. Hard disk is always free because it's not have the sufficient memory. Okay, it's in the disk and it's pretty slow. Let's wait for 1 or 2 minutes and then okay, see this one is completed. Now other resources are allocated to USG queries and those will be faster. Okay, now it's all more completed. See now wait a second. Okay, all are completed very quickly. Okay. Last point we will see. Okay, so this is in the static mode. Okay, okay, this already, so I not want to suspend this. Okay, if we are not critical selecting the auto resume, this is the last part which we get. Okay, 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 I will suspend it manually. It's static condition currently. Okay. Then I'm running this query. Okay, what error will I get? Okay, it's suspended. Okay, either I have to resume it manually. Okay, then need to run. Okay, so always use the auto resume. Okay, otherwise it will work. Okay, so keep it auto receive. Okay, then it will report that whenever you will access the queries, it will automatically start. Otherwise, it will give the error like this. Show you that. Okay, see that warehouse was in suspended state. Okay, so these are all the points we have covered into the Snowflake warehousing, workflow warehouse, how it's computing data is working. Let me know if you have any questions. You can ask in the comment. Thank you very much for your time.